To find the area of a sector, you just need to think about how much of the circle you actually have. Now, we've already learned that to find the area of a whole circle, you use the formula area equals pi times the radius squared. So all you really need to know to be able to figure this out is the radius. If you knew the diameter, you could always halve that to find the radius. Okay, so going with this, what would be the area of a semicircle, given that a semicircle is just half of a circle? Well, if the whole circle is pi r squared, then half a circle would be half of pi r squared. Notice I use the word of, half of, that's half times pi times the radius squared. So we just take the whole circle and we halve it. Makes sense. All right, what about finding the area of a quadrant? Well, a quadrant is a quarter of a circle. I can tell that because there's a 90-degree angle here on the picture, and these two lengths are the same size, so they must be radii. Well, if I know the whole circle and I only want a quarter of it, I find 1/4 of is times 1/4 pi r squared. We don't write down all those little times signs in between the quarter and the pi and the radius squared, because if there's no sign, we know that it's times. Okay, so these two are quite straightforward. What if I have just a certain part of the circle and I know what part I have because I've been given the angle? Because a sector, we really need to define what a sector is. Well, a sector is just a section of a circle. That's the easiest way to remember it. A sector is a section. So if I want to find the area of just this bit, and it goes from the centre with two radii coming out, all I really need is to know what angle is in there. Now, how many degrees do I have the whole way around a circle's revolution? It's 360, isn't it? Think about if you actually do this and jump all the way around, you've done a 360. So if it's 360 all the way down, then say I knew the angle and it was, I don't know, 40 degrees, and I wanted to find the area of this sector down here. What I'd say is that I've got 40 360ths of the circle, haven't I? 40 360ths. And I multiply that by pi r squared. Okay? What if I wanted to know the big bit, the shaded bit in this sector? Now, a sector can be really big. It doesn't have to just be an acute angle here. It could be an obtuse or even a reflex angle like this one is. Well, in this example, I've been given the angle here in the part that I don't want. And I can see that that's 50 degrees. So just think, if that's 50, what's left over out of 360? Well, 360 minus 50 is 310. So for this one, I would say area equals 310 360ths times pi r squared. Okay, so looking at these examples, what's a general rule that we could come up with that's going to work every single time? Well, the easy way to do it is to say area of a sector, we've already got that written here, let's just use this one. Area of a sector equals, now what did I put on the top there? I put the angle of the part that I want, didn't I? Let's call that theta. Now you might not have seen this before. Theta just shows, it's just a common Greek symbol that's used to represent an angle. So theta over, and it's going to be over 360 every single time, isn't it? Because there's always 360 degrees in a circle. And then you multiply that by pi, and you multiply that by radius squared. And now you have a formula for the area of a sector that will work every single time. Let's have a look at an example now. We have a sector here. We've been given the angle of the part we don't want. Okay, we want to find the area of this shaded part here. Now we can see that the radius of the circle is 8 centimetres, and the part we don't want is 120. So you've got a few choices here. You could either think, all right, what's 360 minus 120, and work it out like that. You could reach for your calculator and do 360 minus 120. That's pretty quick to do. You're probably quicker in working on paper. Or you could even do that part in your head if you want. All right, now 3-line working is what we want to use every time we find areas. So we write the formula first thing. Theta over 360 pi r squared. Why do we do that? Well, If you write this out as the first line on every single question that you do, by the end of the exercise, you will just have committed this to memory and you'll just know it. Okay, so you write that out every time. Also, it gives you a good starting point. On the next line, you sub things in, and it's just a good way to check that you're actually using the right formula. All right, what's theta? The angle that we want, which is this angle. We've figured that out. That's 240 over 360. Now here you can put your times in if you like, because it shows you what you're going to actually put into your calculator. Now radius, that's 8, so we want 8 squared. Now, you might be able to see that this is 2/3, okay, and simplify that in your head. If you can, great. If you're wondering, how would I have seen that's 2/3, don't worry about it. You might also look at 8 squared and go, oh, that's 64. Cool, but to do pi, we're either going to have to use an approximation like 22/7, or we're going to have to reach for our calculator, and the answer that's going to come out is going to be a big long decimal. So there's probably no point doing these parts in your head if you're reaching for your calculator anyway. Reach for your calculator, put the whole thing in, 240 over 360 times pi. Now remember, for pi you need shift and then the button down the bottom, times by 8 squared, or you could just put 64 in if you know that with confidence. And my answer there is 134.04. I'm going to round it off to the nearest whole number. Now what are my units? This is centimetres, so I'm in centimetres squared, and I've rounded it off, so I need to say what level I've rounded it off to the nearest centimetre squared.